Hello. So, dear students, today I will give lecture on force and pressure for class 8 on a topic force and pressure. And as all of you know, in the previous class, uh, you must have studied regarding force. So let us first have a situation in our daily life where we realize force or apply force. Dear students, a force is a physical quantity that is so important in our day-to-day life or even for this universe and for our civilization that we can't live even a single moment without force or thinking without force. Everywhere force is dominant. So let us first have a situation where we can see the force is visible, its effect is visible, force itself is not visible. So in the previous class, you just studied or were taught uh, like force is a pull or push. So in the same way, just here we say force is a pull or push. Now you are looking here in the picture. Uh, some people, some men are pulling a rope in one side, in one direction. On the other hand, and few people are pulling the rope on the other sides. So, do you think that what are they doing? Actually, they are applying a force, exerting a force, and here uh, both of the group of men pulls the rope. Both of the group of the men pull the rope their own sides. So here pulling is the case of force that we see here. And next situation, let us check out. And here, another example of forces in your day-to-day life. In your, if you see your mom will squeeze lemon in kitchen, or you will see the stretching of a spring. When you stretch outwards the spring, you have to pull, and then they're twisting is the situation where you, as for example, you will see that in your home your mom will twist the wet cloths in order to take out the water out of the cloths so that it may dry fast or dry up. Next one is folding. You might have a folding chair in your uh, house, or if you even you can take an elastic stick and you may fold it, and during folding its shape size may get changed. While preparing the rod for the pillars of new home construction, you would have seen that uh, folding or bending of rod were done by applying a force. So these all activities associated with the application of force. Now look at, now force is not visible itself. We can't see force, but effect of force can be felt, can be experienced, can be seen. So here look at, a person pulls the luggage forward and another one push the same luggage in their direction so that The two applied force add up together and this trolley starts moving forward. Next one, force can change shape and size. This is another effect of force. A force can change shape and size of object on which force is applied. Third one, object's size can be changed just when you stretch the rubber, when you squeeze the lemon, their shape get changed, their size gets changed. Now, next one is that a force can set an object, a stationary object. Force can set a stationary object into motion. That means force can bring a stationary object into motion. This is the effect of force. And reverse is also possible. Force can bring a moving object to rest. Here, effect of force, moving object stops while you are playing cricket and you stop the ball uh, before reaching the boundary. You just apply force. And when you apply force in opposite direction of motion of the ball come to rest. Similarly, moving object speeds up or slow down due to effect of force. When you apply a force in the direction of motion of object's motion will speeds up, or if you apply force in opposite direction of motion of object, then object will get slowed down. So, and the third one is that direction of motion of an object can be changed by applying a force. As you are driving a car, what you have to do, just you apply a force on a steering and then you take left or right turn. This happens because of effect of force. So all these are the effect of force. Now, a weighing scale, you must have seen in your home or in marketplace that things are weighed and then sold. Here, weighing scale is what? There is two pen, and if you put some weight on one pen and then another object that is to be measured, that is to be weighed, is placed on the another pen. When both the pen becomes equal, that is a gravitational pull on both the pen are equal, then a scale at this point coincides with the point, fixed point, and then we say that the weight of object is just equal to the weight put on this pen. And this way, weighing scale works. So while weighing, a gravitational force come into play. Next, tsunami. You must have heard regarding tsunami that came in 2004 in our country, and large number of lives and assets lost. And do you know how this tsunami uh, involves a large amount of force and pressure within it that moves with high pressure and velocity. So when it strikes the any obstacle that comes in its way, shattered. And this is so powerful. So this is also a best example of force and effect of force. Now here you say weightlifting. Here also force is applied. You say weightlifter apply a muscular force. Simply you can say contact force and lift up the weight. As you see in this picture, this child apply a force, muscular force, and then lift this object and this weight, heavy weight. Here, While playing, force is applied by the player. While you play football, you kick the football with your feet. Uh, that is, kicking is also the apply of force, the way of applying force. And what happens when you kick the football? Moving football change their direction and even their motion. They either they speed up or slow down. So next thing is here you see this is also an example of force. So far we have learned about the force and various effect of force by looking the pictures or uh, PPTs. Now we have to know about the force is a physical quantity, then it must be measured. So right now we will try to know about the measuring of force. How much force is to be applied to lift a heavy object and lighter object? When someone asks you to lift up heavy object and to lift up lighter object, same amount of force or same amount of effort is not applied. So how can one calculate when and how much force is applied? That's why we need measurement of force. For measurement of any physical quantity, first of all, we need a unit, some standard unit with which we can compare it. So for the force, measurement of force, SI unit of force is Newton. All of you know that Newton was a scientist who gave the concept of force. Therefore, in his regard, the Newton of a unit of force was suggested as Newton. Next, a spring balance is used to measure the amount of force applied. Here you see in the picture that a mobile is there and placed in the pen, and a spring is connected with the hangers. And whatever weight is in the mobile, that extends the spring, and there is pointer attached in the spring, which gives the rating of expansion. By knowing the extension in the spring, we can measure weight. A spring stretches when pulling force act on it. More is the pulling, more will be extension, and we can read more weight of the object, which is uh, hanging over the spring. Now, greater force creates greater extension in the spring, and hence greater weight will be there. So, a spring attached to a pointer which indicates the amount of force exerted on this spring. Next thing, in the previous case, a spring was extended by giving extra load on the peg attached with the one of the end of the spring. That's why spring get extended by the weight of the object placed in the pen. We can take reverse case here. Compression of a spring also can be used as a measurement of weight. So weighing machine or is there. There is a spring, and when we put an object, its weight press that spring downwards. More is the pressing, more will be weight there in reading. So a spring compressed when pushing force act on it. In the previous case, pulling force was applied there. Greater force is there, greater compression will be there, and a spring attached to the pointer, which indicates the amount of force exerted on the spring. So measurement of force and measuring device. Measuring here, a scale balance, a spring balance, all these are the measuring device that is used to measure force. Don't get confused about that. A scale balance and a spring balance both measure force. Now, because you know that scale balance will not work in a space. If you go there in a space, scale balance will not work, because in a space there is no gravitational force in presence there. So a scale balance will not work. But on the earth, a scale balance work. That's why a scale balance also measure weight. So these scale balance, spring balance, all these are the measuring device that measures force. Look here, forces around us. How many types? There are various types of forces around us. Uh, we will discuss it all in next class. First of all, try to understand here. If we consider a force, force can be divided into two types: contact force and non-contact force. So let us have a visual picture in this section, and then decide which one is contact force and which one is non-contact force. So one of the force is gravitational force. The second one is frictional force. Third one is magnetism, magnetic force. So check it out. Gravitational force is that much force which attracts an object towards the center of the earth. That is gravitational force. Because of this force, an apple falls down onto the earth when it is broken from or broken away from the branches of tree. And mango falls down, or when you throw a ball that comes down to the earth again due to gravitational force. Now, mass, an object can have two types of physical quantity: weight and mass. So weight is the force with which earth attracts that object towards its center. On the other hand, mass is the measure of the amount of matter contained in a body. Weight is a measure of the gravitational force exerted on the object. Now, let us talk about. So one more thing here. Remember, gravitational force is a non-contact force because two objects interact each other without being in contact with each other. That's why it is a non-contact force. Now we are going to deal with the contact force. Let us check. Frictional force is a force that always tends to oppose relative motion between two surfaces in contact when they have tendency to move relative to one another. As for example, when you rub your hands moves relative to one another, your palm moves relative to one another. In this situation, force come into play to oppose the relative motion between two objects. So friction can be useful, and as for example, friction is useful in walking and when applying brakes to stop a moving car. Here friction is dominant. Without friction, one cannot be able to stop a moving car, or even one cannot be able to walk on the surface of. A constant friction leads to wear and tear. Friction produces heat. So wear and tear, as for example, parts of machine get wear and tear due to constant friction present there. And in order to reduce friction, we apply lubricants. You must have uh, you must have played carom. In case of carom, you sprayed some powder. Why do you spray some powder? To reduce friction. So friction also produces heat. Due to friction, heat is produced, and you must have heard some of the forest caught a fire due to friction. Two branches of tree when come in contact and move against one another, then heat is generated and caught fire. Similarly, Next force is magnetic force. This force is also non-contact force. This is a type of force which is exerted by a magnet on a magnetic material such as iron, nail, and steel. And even one magnet can exert a force on another magnet. Magnetic force could be attractive or repulsive. And as you see that when two magnets are brought closer without being in contact, they attract, yeah, or repel. So that's why it is non-contact force. Every magnet has north pole and south pole, and north and north pole repel each other, and south pole repel each other. But north pole and south pole attract each other. In this case, we can conclude that like poles repel and unlike poles attract. Okay, so so far we have learned about the uh, force. Now we have to understand about pressure. So what is pressure? Let us check it out. Amount of force acting per unit area of an object is called pressure. If force kept constant and area is decreased, pressure will be increased. That means effect of force will be increased. A sharp object pierces a surface more easily than a blunt object because sharp object has a smaller area and therefore it creates high pressure, and on the other hand blunt object has a larger area, so it will produce less pressure. So physical formula for pressure that is used to calculate pressure is just defined as pressure is just equal to force upon area. It is just equal to ratio of force applied upon area of object on which force is applied. SI unit of pressure will be obtained by putting a unit of force and unit of area. In SI unit, area is expressed in meter square and force is expressed in Newton. Therefore, pressure will have SI unit Newton per meter square. Now, application of pressure in everyday life, just like force here, a bulldozer is based on concept of pressure. Can opener, as you see that a can is to be opened, so a device is used for can opener. A knife, a plane, suction cups, all these are based on application of pressure. Let us check. So today's class is enough for and next class we will discuss about